Let me know if you get any error or if you are not able to see or something. Just unmute and tell me, because I'll be sharing these tabs. Okay, cool. So hello guys, myself Aniket Kharpatil. I am a DevOps engineer 1 at Force Point Company. It's been 9 months to me since joining, and I'm also AWS certified uh, cloud practitioner, and I have done certification for AWS Academy for Solutions Architect and DevOps Engineering. So let's talk with the main agenda of today, which is we will understand what is DevOps. Then we will try to see different aspects which comes into DevOps methodology, which is the CICD, the first and important part, continuous integration and continuous delivery. Next is we will understand something about Kubernetes. Then whatever skills are required if you want to opt into this field of DevOps and cloud engineering. We will understand something about Linux fundamentals. Then infrastructure as a code, which is a which has become a very important part now in industries, and rest of the industry practices which are being followed at production level, and that's how the systems in the world are working using DevOps. Okay. So first thing, let's understand what is DevOps exactly. So you might have been knowing about web programming, app development. Developing is the first thing which any beginner starts with, right? So you first learn to code in any basic language, may it be JavaScript, C, C++. Then we start writing our programs. Then we have web development, in which we can use React, or there are many tools for front end and back end, the Nginx, Express.js, Node.js, all of these. Using this we develop our applications. Or in the field of mobile development, there are also other tools, Swift, Flutter, Android Studio, all that. Then once these applications are created, right, the next part is how you will deliver those to your customers or to your clients, friends, whatever. Because you cannot just simply create the application at your PC or your system and keep it that way, and then you show it to everyone. You will have to deliver your application in some form, so that the customers and clients would be able to access those, right? For that, what we need is operations. These operations include the deployment of these applications on public level, which is via cloud or by some domain or via some servers which may be installed at uh, your own location or something like that. Yeah, so these are the main things which we do when we go from development to deployment, and that is handled by so-called DevOps engineers. So not only that, it includes a lot of things in DevOps. So first part is collaboration between development and operations team. So let's say in your company you are having a development team which is developing some application in, let's say, Node.js or Golang or any other languages, and there is an operations team which is going to look after the workflow of this, like how these deployments will go, or what will be the pipeline through which it should go, the testing, monitoring parts. That is focused by the operations team. And DevOps as a whole, the DevOps engineers took care of this, both development and operations, and it kind of gives an assurance to the company that whatever product you are developing, whatever service you are providing, is going to be delivered to the customer without any interruptions, and it will continue to do it even if there are any errors, or through vigorous testing and monitoring, it kind of delivers the product to the customers in a better way and keeps on doing it continuously. That is called continuous integration and delivery. Next is focus on automation. So DevOps engineers' first motto is to automate everything. We can't simply sit there and write everything. Like, you have written one code, I'll put it to GitHub, I'll do git push, and then again I'll run the deployment, I'll create a Kubernetes pod for it, I'll get the IPs, I'll register the IPs, and then I'll deliver it to customer via those. I register the domain. All those things are manual. So what we do is, first thing is automation. We need automation of all of these things, whatever the DevOps cycle is. That comes then is it aims to shorten the software development life cycle. So the software development life cycle is huge, and we don't want it to be in a single flow. Even if you are adding new services or new product is coming in, that should also fit into your product flow which is being run. Next is emphasize on cultural shift, communication and collaboration. So we need to collaborate with lot of other teams. Like suppose there is a monitoring team, there is a SRE team which is site reliability engineering, there is front end team, UI team, back end team. All these teams would be collaborated by DevOps engineers, since they need to know each and every nook and corner of what is happening inside the company. And it utilizes various tools for automation and monitoring. So those tools I will talk about. I hope you got an idea of this. If not, this image will make it easier. So first step here which you can look is coding, right? Oops. So first step is coding. You code your whatever product or service you are creating, then you build it. For building we can use tools like Docker. Docker builds the application and puts it in the Docker hub or any of the registry which you want to give. Then is the testing part, which is done by the QA, the quality assurance team, or in some companies the development team only does the testing. After testing we have release. So release is something when you develop this product, you give it a version. Like let's say I created a website and website abc.com, and this is my first version of website. So that will be my release. This release will go via deployment. For deployment, what we can use? We can use Kubernetes, we can use AWS Cloud. Inside AWS Cloud also we have Kubernetes services which are called EKS, Elastic Kubernetes Service. So we deploy our application on some let's say a platform. We need a platform for our website, right? We can't just keep abc.com and give it. We will need something which will be controlling the deployment of it. So that work is mostly done by Kubernetes or Argo CD in some places where GitOps is used. So that is the deployment. Next is operate, to build the deployment files, to check whether it is being generated, to automate these things. They come into this operation part. Next is monitoring. So now your application is deployed. Let's say it is running on Kubernetes and it is deployed, it is working. Now you want to monitor it. So for monitoring also, we will find out certain metrics from it. Let's say ki your pod or your service is generating some logs, and we know we put in the testing part we have put some checks for the errors, right? Error checks. Those are being observed over the monitoring, whether there is any fault or error in this part, or in the deployment part anything is not working or crashing. That is taken care by monitoring. And next thing is plan. So once we have the monitoring and done, we plan the release again, and the flow continues. Like now V1 is completely done and continuously being monitored. Now we will go for developing V2, which is next version of our code. That again we will build, test, release, deploy. So for this release part, it's mostly done by GitHub. I forgot to mention it. On GitHub we put the code, or we can use Git, and through that we can deploy it by using certain Jenkins or Ansible. So what Jenkins does is it gets the trigger from GitHub, like you have deployed your new release or you have committed something to your code. That is taken care by Jenkins and GitHub, and then it operates to create a new version of it, and again the monitoring step continues. Like that it goes. So it's kind of vast to understand it, but once you try to get into smaller things like Kubernetes and Linux, then you will get to know how things are working. So what is this CICD pipeline actually? CI is for developers, which is continuous integration. So we keep a registry, which is let's say GitHub registry, and we put our code there. We all do it, right? Whenever you fork any registry repo, or you create your own repo and code and you commit to it, then it is stored in the GitHub repo. CD ensures code can be rapidly and safely released to production. So continuous delivery is deploying this whatever integration code you have written to the production. That is, as I said, it is taken care by GitHub, Jenkins, Kubernetes, and all those services. They are being used here. And this is the very important part of DevOps, CD part. Next, it automates testing and deployment process. So you don't have to manually do everything of that. We write bash scripts, which is the Linux language, or we write the scripts in Python. There are many languages which you can use. Golang scripts we can use. Those are being used to automate this testing and deployment processes. For Kubernetes, we use Helm charts, which can easily do the work for it. Next, enhances software quality and accelerates the delivery. So using this, what we achieve is we actually enhance our software quality. We don't have to be dependent on creating a new version ourselves, then going to some other service. Like, let's say if your company only develops code and you are not able to deploy it, then you will have to depend on some other company, let's say AWS. So Amazon Web Services is a company. So sometimes we are dependent on them, that they will help us to deploy our service on their platform, which is AWS EC2 or AWS EKS, like that. Next, facilitates faster feedback loops and agile development. So we can keep the monitoring. Through the monitoring, we can get if any feedback loops are there, if we are facing any problems or error, we can resolve them. And this is the agile flow of development. So before going to Kubernetes, I'll share you my blogs which I have written. You can go through this blog so that you can get an idea of how exactly the things are done. I share this link with you all. I hope you guys are understanding. You can respond in between if you want. So I have been writing these blogs. You can just go through them sometime, and I'll be adding more in this case. Also, this is the first session. I'll be starting a kind of series for it, so that it becomes easier for us to understand each and every point which we are discussing right now. Okay, this is just an overall overview of what DevOps is. So let's continue. Let's just get here. Yeah. So in this, I'll just explain how things are going to be done. So for beginners who would be watching this, or since you are joined, I'll be sharing this recording on YouTube or some platform. So for those who understand, what we first do is we write our code. Okay, this may be in Python or Golang or JavaScript, HTML website, whatever you write, we create our code first. Okay, any language. And once your code is done, what you do is we need to provide this code, we need to provide this website or whatever we have created to our customers or to our friends or to our clients who want to see this code. So for that, you need to have a deployment. But before deployment also, there are few things which we need to do, and that comes is containerization. So whatever code we have written, we need to containerize it, which is just add this code in a package or something like this. So this is our code which we have written. If you want to deliver it to someone or you want to send it to another machine, now this was running only on your machine. Okay, I'll just add it here. So right now the code was only on my machine. Now I have containerized it using Docker. So Docker is a containerization tool which will help us for containerizing the code. What is containerizing is actually let's say you create a tar file or zip file for the code which is very large, and then you send it to your friend and he will run it on his or her machine. Let's say if it is a Python code, he will take that code, the zip file which you provide to him or the Python file which you provide to him. He will have to install Python on his system. Then he will have to set the environment and all according to the code which you have given to him, and then he will have to run it. So in order to skip this process, what we do is we just containerize our code on Docker, and this will create an image. So what this does is it creates an image of our code. Image as in a Docker image. So this Docker image can be used by anyone's PC. So if this was me at my end, and at another end, let's say user B is there. So now B will be able to get this Docker image and run the code on his machine just by Docker run. What he will have to do is he will have to just run Docker run command, and the code will start running at his machine. Because Docker is set up in such a way that if your code is in Python, if your code is in Linux, whatever system it is, it packages it, it containerizes it, it creates a Docker image out of it, and then it sends that anybody can pull this image, and then it can run Docker command to run the code which you have written. So now user B don't need to have anything. He just need to have a system at his end, and he just have to run the Docker command by pulling this image, and the code will start working at this B end. But this is not a good way where you should share your code with your friends or your clients, right? You need to you need to have it deployed somewhere. For that, Kubernetes comes into picture. So what Kubernetes comes is, it takes this Docker image and it creates a deployment out of it. So what is a deployment now? That we'll understand here. So Kubernetes is an open source container orchestration platform. Before Kubernetes, we got to know about Docker. Docker is a containerization platform which creates containers of your code and creates image out of it. Images as in the sense Docker image, which contains your code in a short form. Now Kubernetes takes those images and it creates applications or pods, or you can say deployments out of it. So I will tell you what exactly is the flow for it. It manages containerized application across clusters. So we can have multiple clusters in Kubernetes, and the clusters can communicate between themselves. Inside clusters we have deployments, we have stateful sets. Inside deployments we have pods and services running. Kubernetes also provides scalability, automation and resiliency. So this part I'll tell you on the diagram. Next is supports declarative configuration and self-healing capabilities. So what Kubernetes has to offer us is, if you create a deployment out of it and in some case that deployment fails out, or inside the deployment you had a pod running. Pod is a machine where your code was running, and in case that pod fails out, so the deployment will automatically create a new pod by the time it terminates, or by the time it gets destroyed. So that is a kind of self-healing capability of Kubernetes that I'll explain you in the diagram. It is a very good part of Kubernetes, and it simplifies deployment, scaling and management of applications. So this can be done with the help of Helm charts or just simple YAML files that help us to write Kubernetes YAML files, and then we can create deployments, services, pods, anything we want on a platform. Okay, so let's get back to this. So this is the part where Kubernetes comes into picture. KTS is the short form for Kubernetes. What Kubernetes do is, it will write a YAML file. So Kubernetes will write a YAML file, and that will create a deployment here. So this YAML file will contain, like, let's say I am having a application of simple PHP application, let's say PHP and HTML code for a website that I have dockerized. I created a Docker image for that, and then I am writing a YAML file for it, which will state that take this image, create a machine for that image, which is a pod. So deployments are actually creating multiple pods for us. Pod is the smallest unit of Kubernetes, you can say that. So this deployment will actually create multiple pods. These pods will be the running of your application. So on these pods, your application will start running. So you got to know now that we write a YAML file in which we will mention that we need to use this image and create an application, which is the same application which you have written, and it should go through a deployment, wherein that the deployment will create pods for your application. So let's say that pod 1 is actually handling the front end part of your code, then pod B is handling the back end, and pod C is, let's say, handling any other microservice, which API or something which you want to use in it. Okay, so these names are actually pod A. I hope you are getting an idea of this. I am not going into much details of Kubernetes, but just for information, I am making sure you get the things right. So deployment creates multiple pods, and on this we can have multiple applications running. We can have replicas of this pod A. So in case pod A is getting any error and it terminates automatically, or something happens to pod A, so before it terminates, another copy of pod A will be created in hand. So this is handled by deployment. The YAML file which you write in Kubernetes deployment, it automatically creates a replica for it before this one terminates. Or if you want to have auto scaling feature or something like that, like pod A is getting a lot of load and is not able to handle the load, or let's say the backend server is getting a lot of load and it is not able to work properly, so the replicas will be created for pod B. So multiple pods will be ready in place so that they can handle the load of this one. So this is the features of Kubernetes. And next is to this pods, how will they be exposing the application to internet is via service. So next part we have is a Kubernetes service. So these services will actually take whatever information you are providing, and that it will be exposing to internet. So this is basically done on cloud. Internet is something like you can use CloudFront or any AWS cloud service or GCP or Azure services or simply put it to any domain. You can configure it in the service. So service actually exposes a application which is present in pod. So that part is done by Kubernetes services, and then you can access it via internet. So this is the flow for development. Okay, development and deployment. This is the complete flow. Next part is so there are a lot of other things in Kubernetes to understand. We have services, config maps, secrets, which we use to provide, like any secret data you have to provide password or client ID secret, something like that. You can have Kubernetes secrets for it. So all those things comes into picture. Next is ingress controllers. All those things can be done. And if you one thing I forgot to tell you is where you will create this deployment, where all this will be created. So you can have, either you can create it on your own machine, or you can have multiple machines at your side, at your company, which will be creating this, which are called servers actually. And another thing is you can deploy all this in a cloud. So let's say we create an EC2 instance on AWS, and there you install Kubernetes and you perform all these things there. So that is being run. So all this structure is running in your EC2 instance. Or another best service which Amazon offers is Elastic Kubernetes service, which creates multiple nodes. So deployments are actually having nodes, and under nodes our pods are scheduled. So let's say this is coming under one node, then you can have another node. So nodes are also one part of it, inside which your pods are and deployments are being running. So EKS handles this very well. In Azure, I don't know, some services there for this also, Azure Kubernetes services. Then in Google also, GCP also, you are having Google Kubernetes service like that. So this is the flow for Kubernetes type. Now what we are having ready is, we are having our services ready, we are having our application deployed ready. But this YAML file which will be creating, so every time you can't write a YAML file whenever you change something in your code, right? Like if you are adding something in the code, then again you will have to create a new Docker image out of it. Again you will have to write a new YAML file. Again you will have to create a new deployment. So we don't want to get disturbed by all this flow. We want this flow to be continuous. Like if any change comes into picture into this, any change is coming here, we should have the ability to adopt that change into this code, into this Docker image, into this YAML file. So that is done by CICD. So this is where CICD comes into picture. So continuous integration and delivery. So what we do is we deploy this code along with this containerization or Docker file which you are writing on GitHub. So let me add that here. Not put, let's say pushed. So this code is pushed to GitHub. Now on GitHub we will set up some triggers, or let's say a Jenkins file. So that is another flow actually, but I cannot add all those things here. So on GitHub we will be having Jenkins file. That Jenkins file, what it will do is, whenever a change is made in your code, like there are conditions in Jenkins file, I will show it to you. I might have it here. So what exactly Jenkins file will do, it creates stages. Like first stage is creating the application. Yeah, so first stage is, let's say, building the Docker image. So any change is coming into your GitHub repo, any commit you have done, that it will take care of. It will add that change, like the git commit will be added. And now since there is a change in the code, that will be triggered here. So it will automatically build a new Docker image for it with a new tag. Okay, that Docker image will be built and it will start running the container, or you can have another condition here. So once that Docker image is created, I want it that you have created a new Docker image automatically whenever there is a change in the code. Now automatically update the YAML file. So inside the YAML file, update the Docker image that now we are not going to use v1, we are going to use version 2. Or let's say there is another change coming in, the version 3 will be created here, and inside here we will tell it that now we want version 3. Now that version 3 will be going through the deployment, and deployment is still running. This flow is not stopping. Deployment is still running. It will send the message to these pods that hey, now don't use version 2, update yourself to version 3. So what they will do is they'll restart themselves. So it will stop and start, but that is also done in a very good way by using blue-green deployment or any other. There are multiple type of deployments which we can actually have, or upgrades. So this is actually what we call a release, that a new version is being released. How to get that version released in our applications. So that way these pods will be updated, your application will be updated to version 3, and then it will be served by internet and your customers will see it. So in order to get that no downtime is happening at the customer end, like I was viewing this website and suddenly this website goes down, so I'll say, oh my god, what is happening here? So actually I don't know that the developer of this Canva is actually updating their code at their end and they are doing it. So there are multiple strategies to do the deployments that we will discuss in the next part of this series. So that's all what Kubernetes has to offer to us. Okay, I hope you got an idea on this. Let me know if you guys are having any questions. Okay, so let's move on to the next part, which is Linux fundamentals. So now I hope you have got a flow of how things are going to work here. Like this you can have on cloud, this setup you can have on cloud. Also we can use multiple cloud services. Like if you want to provide a database to this, you can go to RDS or something like that on Amazon. So Amazon RDS, so this database you can connect it with your deployment or with your pod, let's say with your backend pod it will be connected, right? So if your backend needs to use cloud database, it can use it. If it wants to use any internal database, we can have another pod for it. Like let's say there is one more pod for creating a MariaDB database or MySQL database, something like that, and that can be used. So all these things are present in cloud. So you are having multiple services on cloud. The VPC is there, which is taking care of the networking, whatever CIDR blocks you want to provide. EKS is there, as I said, Elastic Kubernetes Service. So this all things are handled by cloud. So cloud computing is a huge field. You can explore it more. I'll be having more sessions and more blogs on it, so you can stay updated on it. And AWS is really a better one to start with and easier one also to understand. Other than like you can choose anything, but AWS should be the first try for all of us. And they are having many programs also aligned with, like AWS training and AWS training program is there, and I'll be sharing the details and links for all of those. Okay, so you can have multiple services, which is the notification service or queue service, which is SQS. Then event handlers, CloudFront is there, which provides your applications all over the world via edge locations. So AWS is having their own cloud infrastructure present, not infrastructure, their machines or data centers present all over the world, which are called as regions here. So all these regions are available for us to use, and inside each region they are having their own availability zones. So let's say here US East region is there. Here we are having US East 1 availability zone, US East 2. So these two are the availability zones which we are having inside this US East region. And inside availability zones we are having multiple data centers. So inside data centers there are multiple supercomputers which are running, and on one of that we run our code. We rent, let's say we are going to rent one of their machine, and there we are going to run our code. So this is what is cloud computing. So the term cloud means that you are not using your system at or your local system, you are using the cloud system which is present somewhere on a cloud provider like AWS. So coming to the next part is Linux fundamentals. So now I hope you guys are somewhat clear on what exactly is the CICD pipeline. We have come until this part, deployment. Next is the operation, which as I said is being performed by GitHub, Jenkins, Ansible or Argo CD, all that. They can take care of this. I won't go into much details, otherwise it will be kind of overwhelming for us to understand, those who are new to cloud and DevOps. So let's skip that one for now. Next is monitoring part. For monitoring, we are having tools like Prometheus, Grafana, or inside AWS also we are having CloudWatch logs, CloudTrail. All those things can help us to perform monitoring. So what we achieve via monitoring is that whenever your code fails or your application is failing, you can get a notification. You can get a notification. You can check what exactly the problem is happening, where the problem is happening. You can set metrics like, if my pod fails, if there is a problem in the backend pod, if there is a problem in connecting this RDS to this backend, so that will be triggered by your monitoring metric that this is not able to connect to it. It will show you the logs, why it is not happening and all that. So monitoring is an important thing which comes into picture. And yeah, then it goes on like this only, same flow. Now I'll talk about the aspects which you should have to become a DevOps engineer, and that will do. Before that, I think I should focus on this infrastructure as a code. So next part is actually, since we want to automate everything, but before automation comes provisioning. So you should write something to provision this. Now I showed you the AWS console. You can go to AWS console and create a EC2 instance, VPC, all that. But what if you don't want to do it manually every time? Go there and write it. For that, we can create infrastructure as a code, which is a practice of managing and provisioning infrastructure through the code. Uses declarative configuration files. So it has its own syntax of, for what I use mostly is Terraform and CloudFormation. So Terraform is, you can create .tf files for it. You can have commands like Terraform apply, Terraform build, Terraform run, Terraform plan, like that. So you just write the Terraform, so like that. I want to create a VPC, and inside VPC I want one EC2 instance created, and yeah, I want to assign it an IP and I want to access it. I want to provide some user data in it, which should pre-configure some things in it. So all these things I can write as a code, and I can plan it using Terraform. Then I can apply it like in which region and by using which account I want to create this thing. So this is open source Terraform, and then it enables versioning, testing and collaboration. So that's a very good part of infrastructure as a code. You can have multiple versions, like suppose I created one EC2 instance, next day I want to change its version or update its image or something, that I can do, and it will create another version for it. It will be storing these state files, like I have changed this and that, so that we can have anytime you want to go back or you want to update something, you can do that. So that is also a benefit of infrastructure as code using Terraform or CloudFormation. Testing, collaboration is easier with this infrastructure as a code, as let's say you are having one environment of development. Let's say your company has 3 environments. So here first let's say this is a development, next is QA, or you can say testing environment, and another one is staging, or directly we can say production only. So you need to maintain these 3 environments. So what you will do is you will write infrastructure as a code over somewhere in your GitHub repo, and this same code you can use to create this development infrastructure. With this same code you can create a testing infrastructure. With this same code you can create production infrastructure, so that you will have the parallel flow, right? Like uh, it shouldn't be like in development I'm creating an S3 bucket extra for my connecting to my application or service, and in testing I'm not having it. So that will create an issue. So you can have one infrastructure as a code. You can deploy it multiple times anywhere you want. You can deploy it on your own side also. So this is the benefit of IAC. Yeah, and you can have tags or something like that, so that this is for development, this is for testing and production. Like that we can create in multiple regions, multiple accounts, or anything can be done with Terraform. So that is the benefit of it. So yeah, that was another thing which was left. Now let's get back to Linux fundamentals. So if you want to get into this field of DevOps, development operations, and cloud computing, you must have Linux fundamentals. So you should be having a good understanding of Linux file system and command line, proficiency in package management and system administration. So there are certain commands which we have to do for administering the EKS, not EKS, the Kubernetes environment, the cloud environment which you are creating, so that we need security also, right? Like ऐसा तो नहीं कि someday someone will pop up and he will try accessing my instance, he will just delete everything out. We don't want that to happen. So we should have system administration or identity and access management, you can say, so that only one role, which is, let's say, admin, and only admin can log in and he can do the changes, or the developer should have the access only to the developing portions of the code. He should not be having the access towards the production or staging environment and all those things like that. So that can be maintained with this. So Linux comes into picture. Linux proves to be very beneficial for it. The orchestration or the containerization which I talked about, the Docker containerization, then the YAML files and maintenance of all this can be done on Linux systems, because Docker itself creates the containers on Linux, which it can use a Alpine Linux machine for it. Also, AWS is having options to create EC2 instances in Linux, which can be Ubuntu, Debian. There are multiple ones which you can have. Knowledge of user and permission management, as I said, like you should have restrictions for certain users and whatever permissions you are trying to give them. Like let's say there are multiple files which are helping us to update our application, and we don't want anybody to just go into the instance, login and change anything in that file. We should have permissions for the file, that nobody should edit this file, or this file should be edited only by some automation script or something like that. That you can manage in Linux. Familiarity with networking concept and services. So you should be having a good understanding of networking and services concepts. So for that you can refer to Cisco networking courses, CCNA course it is called. It is a very good course. I use that, so it gave me a lot of knowledge about networking, and it clears almost everything on that case. Experience with shell scripting for automation tasks. So you can have certain portals. There are multiple things available online to learn shell scripting. I'll provide certain sites also where you can practice it. So one of the site is, I guess, Bash Gaming or something like that, which provides a kind of gaming interface, and there you can learn shell scripting and Linux easily. They are having practice tasks and something like that. For Kubernetes also you can have the certification which is provided by Kubernetes itself, the CKA it is called, Kubernetes Cluster Administrator. That is helpful in learning Kubernetes, or else you can find multiple YouTube videos and start learning it on yourself. You can install Minikube. I have written a blog on it, how to install and configure it, and Minikube actually is a playground for us to test and work locally on Kubernetes. So that all things you should be able to do on your own. Only then you can apply, or only then you will be confident to apply to such DevOps roles or cloud engineer roles. So that's what the company actually expects from the candidates. As I said, the skill set should be proficiency in scripting languages like Bash, Python or PowerShell. Any one of this can do, or you should just have basic knowledge. Like no one expects you to be an expert in all of this. Okay, like even we have to look on Google for certain commands which we don't know. So that is okay, but you should have an understanding of how things are working internally. Next is familiarity with version control systems such as Git. So Git and GitHub is of course very important field if you are going into development also, or in the DevOps culture also. Experience with containerization technologies like Docker. So as I said, Docker, you should have knowledge of Docker, how to create Docker image, what are the Docker commands to create it, or how to write a Docker file, how to containerize an application. So all those I have already written the blogs on it. You can just go through it, you will get an idea of it, or you can watch YouTube videos for it. I'll be adding more knowledge sessions on it. Knowledge of cloud platforms such as AWS, Azure, or GCP. So you can start with any one of this. I'll be sharing the courses link which are free, and also for certification you can go for cloud certifications like AWS Cloud Practitioner is the first one which I did. Next is AWS Solutions Architect, DevOps Engineer certification, lot of developer certification, developer associate, professional, lot of certifications are there. You can go for it. Ability to work with automation and orchestration tools like Ansible or Terraform. So yeah, Kubernetes, Ansible, Terraform, all this comes into picture in case you want to have a good skill set in it. So basic whatever things you will be needing is actually this one which I mentioned here. The understanding of CICD, Kubernetes concept, Linux fundamentals, infrastructure as a code, and next is cloud computing. I forgot to mention it here. So this, if you do these things and you create certain projects, you try to understand more on it, you write your own code, you try to write some Terraform code, try to deploy something on Kubernetes and play around with it, so that you will get more confidence on how these things are being done. You can understand actually. If you watch certain videos on YouTube, you won't understand it directly, but if you gain some practice yourself, you can learn it in a better way. And I'll be providing certain demos, certain knowledge sessions on each of this, so you will get an idea on it. Next is industry practices. So agile methodologies for iterative and collaborative development, as I said. Use of microservices architecture for scalability and modularity. So what is microservice architecture? Actually, the diagram I showed you, like you created pod, you created a deployment, that is actually microservices. So we separate out our application, like हम एक ही चीज़ में कोड नहीं रखेंगे, like front end, back end, database, everything in a single Docker image, everything in a single code. We will not do that. What we will do is we will have multiple small parts of our project. Like let's say there is an application for hotel booking. So for booking and all those things, you can have a backend code which you can keep as a separate microservice. For the front end, the design, CSS and all that, you can have a separate microservice running which connects to the backend, of course. And next is for running the services, like how it should be deployed to which users in which regions, and how you should deliver the food or whatever menu items you are adding or something. For that you can have a separate microservice. So in that way we split out our big applications into smaller services, which are called microservices architecture. This helps us in scalability and modularity. Like let's say you have to do some change in front end, so you will directly go to the front end microservice and make a change. If you want a change in back end, you can go there and make a change in back end service. So that way it works. Next is adoption of DevSecOps for integrating security into DevOps practices. So DevSecOps is something which includes security also in the flow of DevOps. So by security measures we mean कि no one should be able to access your applications or your cloud code. You should have identity and access management in a better way. You should have resiliency for your code. The secrets and the credentials which you are using should be secure. The network, most important thing is the network. You should have private, all your code and all your applications should be in a private subnet or in a private network. It should not be public at all. Only thing which should be public is the production end, what you are providing to the customers, the URL or the CloudFront IP, or let's say the domain which you have created, that should only be public, and rest of the things should be private. So this is where security comes into picture. Implementation of observability tools for monitoring and troubleshooting. So as I said, there are tools like Prometheus and Grafana which are being used for this thing, monitoring and troubleshooting. So those are very good tools. You can create dashboards on it. You can view your application status, whether it is running or not, or whether there is any problem in certain parts of code. You can identify that through this. Emphasis on continuous learning, improvement, and knowledge sharing. So yeah, we keep sharing our knowledge. We keep growing on this field, improvement, and so yeah, that's all. We keep reading the documentation, the Kubernetes documentation, AWS documentation. All those things are already provided. We just have to go and learn those things and grasp that knowledge. That's all, and then you are ready to become a DevOps engineer. Alright, so that's all I was going to share from my end in this session. Anybody of you are having any questions or what? I know it could have been an interactive session, but as this is a first step to get to know about DevOps, so that's why I have skipped those parts. But yeah, you can ask the questions now if you are having anything. I hope you guys are there and not sleeping. Hello.